So welcome to our CCNP ENARSI class for the 14th of June, second day of class. Thank everybody for being here. I am trying to see why my reservation is missing because I did actually a class reservation for everybody. If you're not logged into NetLabs, go ahead and log into NetLabs for me. We're gonna get in there together as a group. I did grade today. I am behind grading. I apologize. It takes longer to grade these troubleshooting labs because I have to go through and look a little more carefully at what's going on the configs. I can't just read the final configs. I have to actually look all the way through and see what you've answered. Several of you are not answering the trouble ticket questions. In other words, in the lab, when there's a trouble ticket, and I'll show you that in a minute, and you've got the Word document open and you're using the Word document, make sure when you upload that document to me, you tell me what you fixed for trouble ticket 1, trouble ticket 2, trouble ticket 3. That way I can see it. Also notice, and I understand this completely, one or two of you found the problem with the first trouble ticket, which was an incorrect default gateway on the DHCP, and you just didn't bother fixing it. You just put that as what the issue was and what you would have done to fix it. I'm cool with that. Because you figured out what the problem was and why the PCs were not getting an IP address. By the way, the very first lab, the three issues were the incorrect default gateway on the DHCP pool. There was a IP helper address on the wrong interface, and then the last one was no ND other flag, which is basically the stateless DHCP flag for DHCP version 6. Rodrigo did what I did also. Rodrigo did on one of the labs, or the lab with the incorrect DHCP helper address. Instead of taking it off the other interface, he just put it on the correct interface of 001. I did that, and I didn't count off for that because you never know. The other interface technically shouldn't need a helper address, but I left it on there and it still worked fine. So if you did that, you were able to do that. So just to kind of throw that out there so you'll know on that very first lab what the issues were. I have placed in here again, don't forget, I placed in here the instructor lab source file so you can check in case you don't know what is wrong. You can use those as a last resort, and then that will tell you exactly what is going on. I am going to go in there and show you the process of the lab because I think there's some confusion about how the lab works and there may be some issues. And honestly, Corey, there may be some issues with the labs. I had somebody actually gave some access to these labs for free so they could study for their ENARSI. When we brought the new pods online, they did all the labs and said they all worked. But of course, there could be issues going on. So I just want to make sure everything's good.
But I don't know of any reason why you shut one interface down on a router and the interface on the other router stays up.
Me either. Yeah. I don't know about that either. Well, I do. Okay. Because there is a control switch in between those. So if they're not directly connected to one another and there's a control switch there that's creating a VLAN between those two, it could be that control switch interface is in, say, a VLAN 100, and you take two cables from the two routers and plug them into that VLAN 100 to make it look like a crossover cable. And so if this goes down, it's in a different port on the switch versus the other one, and that could be an issue. That shouldn't happen. That shouldn't be a possibility, but I'll check on it. I'm going through all the labs myself and making sure, seeing what's going on. So I'm gonna do a little deeper digging to see what's happening. The weird thing too on these labs, don't forget, we don't put the IP addresses on the actual Ethernet interfaces. It goes on the VNet bridge. That's also something to keep in mind when you're looking for DHCP addresses and things. When you do an IP config, make sure you're looking at the VNet bridge NIC and not the physical NIC. So I got confused on that myself, in fact, in the lab. But let's talk a second about troubleshooting EIGRP for IPv4. Just a couple things about EIGRP. It does maintain a neighbor table, it maintains a topology table, and it maintains a routing table. Quick question: what is the type of packet that maintains the neighbor adjacency? Anybody tell me?
Is that a router advertisement?
Not the advertisements. It's how do they talk to you?
Solicitation?
Nope. Don't think about DHCP. Think about EIGRP. 5 packet types in EIGRP. What's the very first one? When you walk up to somebody, what do you say?
Announcement, hello.
Hello.
packet.
Hello packets, right. Yeah, the hello packets are what are used to establish the neighbor relationship. Now, there are going to be some things about the neighbor relationship that are a little weird, and that is that in order to create a neighbor adjacency, it does use 224.0010 or FE::A, which is 10 in IPv6 when we get into the next EIGRP for version 6 or EIGRP v6. In order to become a neighbor, you must have the same autonomous system number. You must have the same K values. You do not. Now, here's something that's weird, and this is confusing to people. Notice in this list, is there anywhere in this list where it says you have to have the same hello and downtimers? No, it is not. What happens with EIGRP is if there's different timers, okay? Now, it says here, they do not have to match. It could flap. But most of the time with EIGRP, what'll happen is the two neighbors will talk to each other and say, oh, you want our timers to be this? Okay, I'll use those timers. They may flap once or twice until they agree on the timers, but in the real world, EIGRP timers don't have to match. Now, having said that, it's a very bad configuration to have them not match. So I would definitely say that. However, your autonomous system number has to match. You have to have a network statement for the link between the two individual routers. You have to have a same K values. You have to make sure there's no passive interfaces or the interface between the two are not passive. They could be on different subnets. Again, if the ports on the two routers are not on the same subnet, they're not going to talk to each other. Authentication, if it is enabled, a lot of times it's a key string mismatch. In other words, there's a missing authentication key or the key string is wrong. And then there could be an ACL blocking 224.0010. They even get into, there could be distribute lists that are actually pulling a route out. That's getting pretty advanced, but that is in this. So be aware that if everything looks right and it's still not working, a route's not going across, check to see if there's some type of distribute list being used to take a route out of the advertisements. Same primary address subnet. Correct. Yep, that is correct. So they've got to be on the same network, whether it be a subnet or a primary. Yeah. So otherwise, it's just like any other two devices on a network. If they're not on the same subnet, they're not going to talk to each other. They're not able to do that. Here again is the autonomous system numbers, which is, remember, this is really not an autonomous system number. Oh yeah, versus secondary multiple addresses. Yes. We don't deal a whole lot, and I know, Eric, we can put secondary addresses on interfaces. We don't deal a whole lot with secondary interfaces. We don't really deal a lot with IP unnumbered or with sharing interface IPs, although in the real world that is a possibility out there. You can do that. Autonomous system numbers is kind of, again, a misnomer in EIGRP because they're not IETF autonomous system numbers like BGP uses. These are really more like just a work group ID, to be honest. Okay. You can see this though. You can actually go out here and do a debug IP EIGRP and see where the hello packets are, looking for the autonomous system, and it will tell you what the autonomous system number is for the hellos, and then you can see if they're the same or not on both sides. Incorrect network statements. Here we have, when we go into EIGRP, we may put in a network statement that is incorrect. So we accidentally do something like this, which is trying to route for just a single network. Okay. It's possible. This could be this. All right. We also have the ability to do quad 0, quad 255 that says all networks, which is kind of a nice thing. OSPF does that too. We have inside of our networks or inside of EIGRP, remember our K values are set up for our metric. Let's back up and do a quick review. What are the two values, K values, not set to 0? Anybody remember what the two that's not set to 0? There's only really two values that are used by default.
You said the ones they only use were K1 and K3, right?
K1 and K3, which is bandwidth and delay. Yep. Bandwidth, the lowest bandwidth in kilobits per second, plus the sum of the delays. Okay, so exactly, Charlie. Yep, 1 and 3. So just have to make sure those have not been changed. And you can see here, K1, K3 are set to 1. You can change those values. Only do that typically if you're talking to support and there's a reason to do that. Passive interface. People get in trouble when they do passive interface default and then forget to remove passive interface from the interface that actually needs to be non-passive. So if you got a router that's got a bunch of interfaces that go to host, and then it has one network or one port that goes to another router and needs to share EIGRP information, passive interface default takes care of the 6 routers, 6 interfaces going to host. You forget to turn the other one off, boom, they can't talk. Pretty common there. Mismatched or different subnets. Here's an example of different subnets. 255, 255. Let me see. That's on 10.1.12.1, 10.1.12.2. Those are actually on the same subnet there. But if you're not on the same one, it will even tell you it's not on a common subnet. All right. I want to do something real quick. I want to take everybody up to NetLabs. I'm going to enter this lab, and what I want to do is I want to show you a very nice looking Grey Death Legion Marauder and Warhammer. But other than that, I want to take you into NetLabs, and I'm going to pop this content window open. And I know I need to bring up the one that's for NetLabs, and so that's why I'm using this one instead of going in the Word document this moment. But we're going to look at this. We got a router on a stick. We've got these 3 devices. I want to walk through the process of how we get the scenarios up and running. So let's take a look here. So R2 is added to the network to increase bandwidth. However, R2 is not sending routes to R1 or forming an adjacency with R3. So we've got 2 issues. We got to figure out why it's not forming an adjacency and why it's not sending routes. All right. So the first thing we got to do is we got to load our config. So we're going to copy /NARSI, and you can actually do either with or without that. 4.1. Now the good news is you actually can, what is going on? 4.1.2.1 and then tab it out. It's only got the R1 config in it. So use the tab key to save yourself time, and then do it to run, and away she goes. We got R2.
Copy and paste works real well too.
Do what?
Copy and paste works real well too.
Yeah, you can do that too. I can get pretty quick with it like this here when I do. And then this is 1. Oops, not 2. 1. And then we do run. So this is R2's config. R3. Oops. EB is not going to work. Anybody remember the old store, Electronics Boutique, way back in the day?
No.
Golly, I'm showing my age. I'm going to do D1 while I'm waiting. In copy /:again.
Electronic boutique, what, like Radio Shack?
Yeah. Oh God. Yeah, that was way back in the day, wasn't it?
My hometown had a small franchised Radio Shack that was just like some old guy who was running like a boutique electronics store, and he would solder custom speaker cables or stuff if you needed him to. You just walk in there.
I tell you what, I miss the old Radio Shacks because they had that the one amazing thing was back in the back where they had all the resistors and I mean they had everything. They had everything you could possibly need or want. It was awesome.
Nobody knows how to do small board component swaps anymore.
No, you throw it away. You just throw it away and get a new one, unfortunately. Yeah, it used to be you'd get all kind of stuff like that, but not anymore. All right.
I remember TV repairs.
Do what?
I remember TV repairs just barely.
Yeah, yeah, yeah. That is so far gone from what we do now. All right, so now once I get them loaded, I actually do a show IP brief to make sure they're up and running. Okay. All right, so we're all up and up, and I do have a neighbor relationship. So I've got some kind of neighbor relationship. Let's see what it's telling it's got. We've got R2 is added. R2 is not sending routes to R1 or forming adjacency with R3. So the first thing I want to do is I want to do a show IP EIGRP neighbor. All right, so let's see what we got. So our neighbor relationship here, we've got 1, 2, and we got that. So let's take a peek. I need to make this a little bigger, folks, so I can see it better. I'm old. All right, so we got a 1, 2, and a 10, 0, 12, 2. So I got to go back up and look here. So I'm on R1. I got a 1, 2, which is 176.12, which is R3, and a 12.2. So I've got a neighbor relationship with it. Let's do a show IP protocols. And we'll see that we are part of routing protocol 412 is our autonomous system number. I'm gonna just check my K1s. They look the same. Everything's good there. So we're not exchanging routes with R2, correct? R2, okay, so let's go to R2. Let's do a show IP prot. EIGRP 412. That's good. Let's do a show IP EIGRP neighbors. Actually 12 ones, we're seeing that. So we're good there. So, all right, so far that's good. Let's take a peek here. We could do this. We could do a debug IP EIGRP. Let's do question mark. Let's do neighbor and do 10 dot, and this may not get us what we need, but let's try it. Let's do neighbor 10.0.12.2, 10.0.12.2, 10.0.12.2. See if we see anything. I may do a clear IP EIGRP process. Yeah, so let's see if it'll let us do this here. Neighbors. All right, let's see what it'll do. See if we get anything here. All right, so clear neighbor, manually cleared, says it's got an adjacency. So that's 3, that's 2. Okay. So IP. Let's do our interfaces. What else could we check? We could check, let's check, make sure our gig 000 between R1 and R2 are on the same network. So show int G000. All right, so this is on 10.0.12.1/24. All right. So let's check gig 00 on show gig 000. Okay, 10.0.12.2. So we're still good there. Let's go back over here and do show IP protocol. We're good there. We're good there. Okay, let's do one more show IP protocol. You're gonna notice this one is something weird's going on. Look how we don't have, there's nothing going on here. So it looks like there's no networks being displayed. So let's try something. Let's do a show run is not a troubleshooting command, but at this point I noticed that there are no networks being shown for EIGRP. So let's try show run, see what we got in terms of our EIGRP configuration. We're good on here. All right, so we've got our network statements, but for some reason it's still not doing what it needs to do. Now I see the error here, and this is actually a very sneaky error because it's forming an adjacency, but what's this? Okay, let's do a show IP EIGRP neighbor. So it is forming an adjacency, but there's a
Were
reason.
they putting in wildcards instead of subnets?
No, that works fine.
Okay.
Take a peek right here, folks.
It's the router ID. Or
That's 111. And that's 111. They both got the same router ID. So let's go back over here. Let's fix it. Config T router EI GRP 412. I've got to spell, you got to spell EI GRP right. EI GRP. Oh, go. 412. No, yeah, GRP router ID 1.1.11. And I think you actually can just overwrite it, but I'm being extra careful. 2.2.2.2. Okay. And Control Z, and then probably I would still do a clear IP GRP neighbors and drop that to make sure it clears it out. And now let's see if we have what we need. So we're not sending routes. We're not sending routes to R1. So let's do now a show IP EI GRP route. Or just show IP route. That's even show it better. Oh, all right. So let's see if we've got the network 10.0.23 in here. Yep, there it is. So there it is. You're also going to see here now, if we go into R2, watch what happens. We should be able to see show IP prot. We should see it actually listing now that it is actually sending or routing for those networks. So error number one in this particular setup was the router IDs were the same. Now, what was a way to see this as a giveaway or something that kind of led us that path is when you do a show IP route or show IP protocol, okay? And you'll notice that there's nothing being shown in terms of routing for that protocol. You were getting just the basics. Okay, so there was nothing being shown here. It was showing you that, and it was not showing that. And even though if I went into show run, it showed I was actually supposed to be routing for those two networks, but I was not. So that is a weird one because it did form an adjacency, but it did not send routing updates. Okay. Now let's look at R2. And our next issue is we got to figure out why R3 and R2 are not forming an adjacency. So show IP EI GRP neighbors. All right, so I see my only neighbor is 12.1, so I'm obviously not forming a neighbor relationship with R3 down here over the 23 network. Okay, let's do a show IP protocol. Am I routing for the 23 network? Yes, I am routing for the 23 network, so we're good there. So that is true, so we're good on that one. Let's go to R3, and let's do a show IP prot. And we will see that we are routing for the 23 network, which is correct. Show IP EI GRP neighbors. And we can see just R1 across our Ethernet link down here. So let's look at what else could be in here. Okay, so we've got an adjacency with R1, but not with R3. Let's do this. Let's do. Okay, variance is 1. That doesn't matter. Summarization routing. Okay. So let's do a out. So we're getting it just from R1, which is correct. Only R1 is talking to us. Now, what I'm going to do is I'm going to ensure I can ping across it. 10.0.23.2. Because if you can't ping across it, you're not going to route across it. Okay, so I can ping across it. So I've got pingage from R2 to R3. And I'm going to R3 and I'm going to ping 10. 0.23.1, which should be back across. So I've got that. Now I'm gonna do a show interface G001 12/24. I can ping across it, so I'm gonna assume that that's good. We're at AS412, so we know we're good there. We could try. Now this one, folks, I do want you to know about the topology table. This is showing you all of, well, it does not show you all by default. What is the topology table? If you just do show IP EIGRP topology, what does that show you in the table?
Just the current routes?
It shows you the successor routes. And what is the successor route? That's the best route, right? Okay.
Yeah.
It will also show you the feasible successor routes. It will not show you any route that does not match the feasibility condition. If you need to see every single route in the topology table, you must put the all links command to see every single one of them. All right. In this scenario, there's no difference. 1, 2, 3, 4, 5, 1, 2, 3, 4, 5. There's no difference. But in some larger networks, you may have a backup route that does not meet the feasibility condition. And remember, that is the reported distance must be less than the feasible distance of the best successor. Okay. I'm going to cheat a little bit and look through here and see if we've got anything that's jumping out at me under my EIGRP. All right. So notice where it's at. Where's our problem? Router ID is fine. Okay, it's passive. Yep. You'll notice right here, they did passive interface default. And by the way, this is this named or traditional config? That's traditional config. It's not named config. They forgot to do no passive interface gig 001 or gig 000. They did 001. Okay. So we go in here to config T. We do router EIGRP. I got to put in 412. They just missed a classic opportunity to do 420. I mean, really, they should have. Let's be honest. No passive interface G000. All right. Now, at this point, we've got a new adjacency. And we go to R2, we'll see our adjacency is there now. So we do a show IP EIGRP neighbors. So we were not getting any neighbor. You also could do this. You could go, let's go back and put this back in. Now let's make it passive. Okay. You could or should have been able to do this. Debug EIGRP, debug IP EIGRP, neighbor. Okay. And you also should be able to do 412. Okay. And what should happen is you're not could use unicast command. Yeah, you could do that too. You shouldn't see any on this any hello packets. There'll be no hello packets come through. And that would be a big indication that you've got problems with the interface. So I'm going to do no passive, bring it back up. Now, what I want to do is I want to walk you through what we do next. So we just solved this one. So I would go in here if I was doing this and I would write down issue 1 was R3 did not have, or excuse me, R2 had the same router ID as R1. Issue number 2, the interface between R2 and R3 was passive. Cool, I'm good. So now I got to go to the next troubleshoot ticket. Now notice what it says here. You need to do the following. Put that in your item. Now you're going to go to each one of these devices and you're going to type reset.now. And you're going to go to each one. Now this is why you've got these labs take us more time than some of the other ones. Because you've literally got to go to every single one of these and do a reset.now, and that runs a tickle script or tackle script that a TCL script, however you pronounce it. Everybody's got their own way. Nope, that's not it. Reset.now, not reset.tcl. Okay, and it actually will do a reset. It erases the startup config, reloads the device. That's why you're getting all these bounced interfaces, because it's actually doing that. So I'm going here and reset. God, I can't type now. Okay, so now it's going to go in here and get rid of everything. And so all these devices are rebooting. So we got to wait for it to reboot, which is a pain, but you need to do that. And then you're going to load the next item, the next trouble ticket.
Do we need to change the banner message?
I don't. No, I wouldn't even bother doing that. Don't waste your time on that, because I mean, literally, I'm not going to go look at that. What I look at is just to see whether or not you did any. What I'm looking at in the labs is, did you do any troubleshooting commands, and did you try to fix the problem? That's what I look at when I go look at your labs. So I go and look at. I can see every single command you type in. So if you don't do anything at all, I know that. I can see it. Now, some of these problems are so simple. Like, honestly, that the first one, you could have probably found it with just one, or you could find it by looking at the config. But realize something, folks. We have, as part of this exam, okay, this exam has right here, when we look at our objectives, you're going to have questions on the exam that ask you to troubleshoot. So you're going to need to know how to look at these things. You're going to have to be able to troubleshoot these items, relationships, neighbor relationships, troubleshoot security, troubleshoot. You're going to have to be able to do these things. So make sure that you are not just reading the issue and going forward. You need to know how to look for the different problems that are going to be there. Okay. So let's go back, jump back over here just a second to here. We're going to expand this while those things are rebooting, and we'll look. So in this case, notice that none of these, I love how all the different items they gave you here, and then they gave you an item in the lab that had nothing to do with the items they talked about, because it was a mismatched router ID. And that is, I'll tell you that is such a weird little thing. I would just about guarantee it will be a question on the exam or something similar. Okay. All righty. So debug EIGRP packets. Again, you can look at that, and that will show you hello packets. Passive interface, we looked at that. Authentication, ACLs. Now, routes, EIGRP routes. Typically, it's a missing network statement. A better source of information, in other words, maybe you've got a route to the same network with a better administrative distance. So they've accidentally put in a static route, or they put in something that has a better AD. There is a common problem, and I'm going to mention this one because it shows up on a huge amount of questions that I've looked at before, and that is, way back in the old days, we used to talk about split horizon. Split horizon only applies to distance vector routing protocols. Well, for the most part, it's something we associate with distance vector routing protocols. It doesn't just apply to them, but it is something very, very big problem with distance vector routing protocols. In those distance vector routing protocols, the rule for split horizon is you will not advertise out an interface a route that you learn via that interface. So what happens in a hub and spoke frame relay or DMVPN or anything that's multi-access to an interface, if one router advertises out a network to you, so for instance, in this case, if R1 heard from R2 about 10.1.2.0, it wouldn't, because R2 advertised that across the same interface, S10, that is actually also connected to R3. It learned about 10.1.2.0 on S10, so it will not send that back out on S10. Now, way back in the old days, we used to learn about how to make these into 2 point-to-point links instead of point-to-multipoint. which is still a possible way to fix the issue. But you also can turn off split horizon. Okay, so no IP split horizon. So if you know in EIGRP you've got this type of situation, there's a permanent virtual circuit or possibly a GRE tunnel, and you are not sending updates back out the interface it came in on, you can just turn off split horizon. Now, split horizon was developed originally to stop routing loops. You don't typically turn it off unless you've got a very good reason. And this would be the reason right here, that you've got an actual interface that is trying to send back out a network that it learned on that interface. All right. Y'all remember split horizon? I mean, have y'all been around as long as I have, where split horizon was actually something we taught in CCNA 2 or 3? I think it was back during CCNA 3 we used to teach it when it was a 4-class format for CCNA. Yeah, Charlene, you may be right. It may have been in 4. It may have been in 4 in like the advanced distance vector routing protocols when we talked about it. You're right, it was in 4 because it was part of the discussion of frame relay. That is right. Very good. Well, we're showing our age. So feasible successors, that's the backup route. Remember, that is only going to happen if it meets the feasibility condition, which means the reported distance is less than the feasible distance. So here is not an example of showing feasible successors. So feasible distance, successor, and then feasible successors, because their reported distance is less than the feasible distance. They will show up in the topology table. Feasible successors will show up in the topology table. If it doesn't match that, you've got to do the all links command in order to see everything in the table. Quick question. What happens if there's a feasible successor and your successor route goes down? Will the route go into an active mode? So you got EIGRP, you've got a successor route, you've got a feasible successor route inside of the thing. Hold on 1 second, folks. I got the IT department guy calling. All right, quick question for y'all. Anybody know anything about CrowdStrike? Anybody ever used it?
No.
Okay.
Yes, I've used it.
Okay, what do you think?
I thought it's a great tool.
Okay.
It basically looks over the entire domain.
Okay.
And if there's any issue going on, you can quarantine it. And then you can like wipe it out. So you and you don't even have to, there are different levels. So one level is they will tell you there's an issue and they'll wipe it and clean it for you. And then
Okay.
there's another level where they will actually tell you what it is, quarantine it, and then you can go ahead and wipe it out.
Okay. Okay. Well, we're my IT department, we're looking at that, or we're getting some issues with Sophos and some other things, so we may look towards it. So
Yeah.
I know a little bit about it, but I didn't know much. So it's good to hear somebody's actually used it and thinks it's a decent product.
It is, and the seed on it is real light. You don't even notice that it's on, and it gives you alerts. It'll
good.
tell you what's going on, false. And I told my team that immediately when you see an alert from CrowdStrike, shut everything down, go see what the issue is.
Because it doesn't do many false positives, and it's usually
That-
pretty right. Okay.
That is correct.
Oh, that's excellent to know. Thank you so much, Nancy.
You're welcome.
Okay, so back to our original question. Sorry for the little side, everybody, but that's a good learning tool too. So you've got a successor route. It goes out, and you've got a feasible successor in the topology table. Does the route go active? The answer is it should be no, should not, right? There's a feasible successor. That route should immediately be placed into the route table. And then if a second feasible successor can be found, it would try to find that. Now, if there's no feasible successor, then it has to go active and go and find a new route and put that into the routing table. Now, having said that, I have found that even with no feasible successor, EIGRP is pretty quick to recover from a down link. Definitely. This used to be much more of an issue back in the day when we taught IGRP and EIGRP, but what was called discontiguous subnets. It used to be in the old days that EIGRP before version 15, iOS 15, did auto summary, which meant if you had this set up right here and you were running EIGRP, R1 would, instead of advertising the actual subnet, it would advertise 172.16.0.0/16, and you would end up with R2 thinking that the 172.16 network was available via both R1 and R2. In 15.0 and later, that is already turned off. The no auto summary is on by default. So you actually have to turn on auto summary if for some reason you want it, which I don't think you would. But if you wanted it, you would have to turn it on. But if you run into an iOS version previous to 15 and you're running EIGRP, realize it could be doing auto summary, and that could get you in a problem with discontiguous networks. Load balance, EIGRP will load balance across equal cost paths, and it will also load balance across unequal cost paths using the variance command. And that's something that's pretty common. All right, I'm not going to do these trouble tickets because we are doing those in the lab. But once your lab has rebooted, all right, you just say, no, I don't want to do that. And you will start the process again. And then, oops, let's put this over here. There. And then once that is there, all you have to do is set up for the next ticket. So your next ticket would be 4112. And it takes a little while to do all this. So we're obviously just going to go in here and copy /ENARSI 4, and this will be going to give you 2, and then we're going to run, and boom, away we go. Okay, so and then do a show IP and brief to make sure our interfaces are up. Okay, they're down right now because the other interfaces are down on the other devices, but we can go through and run all these, and that's the process with these troubleshooting tickets. So I want to make sure you're aware of those. Questions on those? Anybody have any problems with them? I know, Corey, you've had problems, and I'm still trying to figure all those out. We'll get those figured out. Okay. Well, let's do this then. Let's go back over here and let's pop up here. I do want to go into 5. I want to talk to you a second about something else too. Inside of NetAcad this week, it is IPD week, so it's Instructor Professional Development Week. So if you haven't signed up, you need to go to Instructor Professional Development and go down and enroll in IPD week. Okay, I'm already enrolled, so when I click launch course, I go into IPD. So they're having sessions this week on all different types of stuff, AI and education. You'll notice this right here, which is supposed to take place here shortly. Yeah. So CERT roadmap, right now, our CCNA CERT roadmap says that sometime this month or next, we will get a new CCNA certification roadmap or new certification objectives. And then it looks like we'll have a new CCNA sometime early in 2024. So that's what I expect to see from this. That is off of Cisco's website, not the NetAcad site. So I would suggest that even if you don't do this today, you can actually go in and watch it later. So I'm getting ready to watch the AI education and also the program update a little bit later. So you can always come in here once you've enrolled in IPD week and you can watch the recorded sessions. The recorded sessions are here for you. Okay. So please do that. I strongly suggest, again, you go to resources, instructor professional development, enroll in IPD week. If you're already enrolled, by the way, you also can just go to I'm Learning, and IPD week always shows up on your I'm Learning tab. And then you just launch the course and it takes you directly into it. Questions about that? This, by the way, is a special. This June 12th to the 16th. And so there are also some special sessions during here that talked about the new CCST and how to become a testing center, Certiport testing center. We are actually looking at possibly becoming, buying a site license for the CCST that would let us allow schools underneath us to proctor and be able to give the CCST using our vouchers, but we'll see about that as we move forward. All right, we're getting toward the end of time, but I want to hit this real quick. This is our last thing this week. EIGRP for IPv6 is honestly just EIGRP v6. It runs exactly the same. It does neighbor relationships. It has adjacencies. It has topology table. It has a neighbor table. You'll notice it uses FF02::A, which is 10. Remember, before the multicast address was 224.0.0.10. So this is FF02::10. And so you'll notice that's used by updates, hellos, and queries, all of that. So instead of multicasting like EIGRP, it uses the multicast IPv6 address. There are two modes, classic and named, just like our current EIGRP mode. And so you can either do it by AS number using classic and then put in your network commands using network statements, using the interface. Actually use the interface parameter. You don't use network statements in IPv6. In IPv6, you set up EIGRP and then you go to the interface and join that interface to an EIGRP AS revision or number, and then every IP address on that interface is then going to be advertised into that autonomous system. In named configuration mode, you do the process with a name, so you do a process name instead of autonomous system, and then you have to do your address family, IPv6 autonomous system number, set your ID, and by the way, the router ID is a 32-bit router ID, even though it's IPv6. It's crazy, but it is. And then you go in here and either say, you can actually then put your individual interfaces into the address family. So in classic mode, you still go and put this on each individual interface. In named mode, you can put the interfaces in under the named mode configuration. So you'll see it classic mode. We're going in, we do IP EIGRP, IPv6 EIGRP 100, which joins gig 01 into this 100. In named mode, we go in here and we put the router IDs and we use the address family information to put our interfaces under the named mode. Let's see, I don't think don't forget default information originate, which is how we do, that's under IPv6, that's under OSPF. Inside of EIGRP, we actually have to tell it to do summary advertisement. So you got to put a default prefix in here and use the summary method. We've got route filtering. Neighbor issues, typically same thing. It's either you've got a mismatched prefix You're not sharing the prefix between the two, or the interfaces are not in the same autonomous system number. So mismatched autonomous system numbers, mismatched K values, passive interfaces, and authentication. So you'll notice, and timers, they don't have to match, but it can cause a flap. You'll notice IPv6 or EIGRP v6, the same exact issues for neighbors as EIGRP for IPv4. So I'd also remember that the router ID could be an issue. We've got the same issues that we had before. Now, if it's not in the router process, you can do show IPv6 process and see what interfaces are in the process. It will also tell you who is passive. So show IPv6 protocols will show you that EIGRP information. There could be an ACL blocking FF02::A, so denying multicast. That is not common, but it could be there. So just be aware, look for an IPv6 ACL and ACL. And then looking at our different troubleshooting, it could be it's not participating in the routing process. So make sure it's actually been placed into the process via the classic mode or via named configuration mode. There could be a better source of information. What, by the way, is the administrative distance for, well, it's already here, done messed up. What's the base administrative distance for EIGRP? It's 90. So remember that. So if we get something better than 90, it's going to go and put that into the routing. Yep. Internal is 90, external is 170, correct. Very good. Look for a route filter. That can always be, you can look out and see if there's not a prefix list in here. So if they put a prefix list in, that's going to then have to go look at that prefix list and see what's being filtered in or out. If the wrong router is configured as a stub, you can end up with it not allowing routes to be actually advertised. So remember, with a stub network, it will not allow advertising out. Split horizon still exists. So again, you may have to end up with checking split horizon and disabling it if you've got a multi-access frame relay or GRE tunnel. And look at this sample name configuration. Let me zoom in on this and let's look at it real here before we call it a day. So we got it, router EIGRP name. So there's our name. Address family, IPv4, autonomous system 100. So we do IPv4. And we've got our IPv4 information in here. So we've got our networks, we've got our router ID, we've got our, telling it it's a stub connected summary. So it's going to send a summary address or summary information. And we got our IPv6 as part of autonomous system 100. And we tell it passive interface. Okay. Then we do no passive interface on 1.0. So default, by the way, you'll look at this. This means address family interface default is for all interfaces to be passive. But then we go into 1.0 and tell it not to be passive. So it will participate in EIGRPv6. We've got our maximum pass. Our variance has been set inside the family. And then we got our router ID, which is 44, 44, 44, 44. And then we also have this set up to be a stub, doing a summary, connected summary address. So we can do named. You can do show IP EIGRP protocols to see the named information. So it will show your IPv4 settings and it will show your IPv6. Notice that it will show you autonomous system numbers, K values, router ID, whether or not it's a stub, the AD, maximum pass, and the variance. So that is a good, quick way to do a look at how your EIGRP is configured on a device. Questions? All right. Well, folks, I think the first 5 chapters is where we're at right now. So we look at our schedule. We look at our syllabus. After today, we should have in the labs for the first 5 chapters. And it is time for you to take the first exam, the 1 through 5 exam. I'll make sure that exam is on or should be on for everybody. I added a bunch of people kind of in different places. So if I miss somebody and you go in there and try to do the exam and it doesn't work, please send me an email and say, hey, Kelly, the exam's not on for me. I'll go get it turned on for you. All right, but it should be on for everybody. And then we will start next week looking at chapters 6 through 8. Okay. Now, next week, I am in Atlanta for the Skills USA National Contest. In fact, that's what I've done most of this week is written the national contest. I'm gonna try my best to still have class on Wednesday. Let me think about that. Wednesday's a contest day. I'm still gonna try my best to have class on Wednesday. If something comes up, I may have to cancel it late during the day Wednesday. So I'm sorry, please be a little flexible with me if you don't mind, but I'll try my best to actually get in. I will probably be at the convention center in the convention site for class. But let's still plan to have class next week. I'll do everything I can to get in and make sure that happens. Okay. Any questions about anything we went over? I'm gonna go ahead and end my reservation so that we can free this up for somebody. Any questions on the trouble ticket items? Any questions on any of the stuff we've done so far today?
I have a question for you on the labs like 2.1.2, which is an implement EIGRP.
Yep.
What do we need to submit for those?
On those, just submit the lab document itself, and I will go and look at the config at the end on those. Yeah.
Okay.
On those, don't worry about dumping your config in on that, because what I'll do is I'll go and look at your final config. Just submit the document so that I know that you've completed it and I need to go look at it in NetLabs. So if it's an implement where you do a configuration, all you need to submit is the document, unless there's questions in the document. Now, if the document has questions in it, answer those questions and submit it. If it does not, just submit the document and I will go look at the configs and see what you've got there, okay?
Yeah, I've had
the lab Word documents. Word documents are fine. Word documents are either way is fine, Charlene. As long as you do submit something, so I know that you've completed the lab. So that's fine. That's not a problem. If you've been uploading, where you've been uploading in the implement just a document saying these are my answers, this is what I did, that's fine. Because with the implement and all the ones that are not troubleshooting tickets, I go and look at the final config to see if you've completed the task. Okay.
Now, should our output or show outputs be the same as what's in the lab instructions?
They're going to be fairly close. They'll be fairly close. They may not be exact. They should be fairly close. Yeah.
Okay, yeah, because I've done this one a couple times and
yeah, they may not match exactly. No, they may not.
Okay.
Charlene, on the ones that are trouble ticket ones, yes, I do want the problem found and the solution. So yes, if it's a trouble ticket, I want both. Say this was it, this is how I fixed it. Okay. Any other questions on our CCNP class? All right. Thank you, everybody. I really appreciate you being here. I appreciate your time. I'm going to stop the recording.